All right, hello everyone. This is Jeff Scott of Rankin Technical College, and what I'm going to be doing, starting right now with Chapter 1, is going through the PowerPoint presentations for the Microsoft Visual C Sharp 2015 An Introduction to Object-Oriented Programming text by Joyce Farrell. This text is used for the C Sharp class for both the IWT and AWD programs. It'll be for the fall 2016 semester at the Rankin campus in St. Louis and spring 2017 at the Rankin campus in Wentzville. So let's just start with Chapter 1, a first program using C Sharp. Here are our objectives. Learn about programming. All right. Learn about procedural and object-oriented programming. Learn about the features of object-oriented programming. Learn about the C Sharp programming language. Write a C Sharp program that produces output. Learn how to select identifiers to use with your programs. Now, a couple things about this. This is a kind of a typical chapter that you'd see at the beginning of a book. And they're going to show you a lot of different things. So if there's something that happens in here that confuses you, don't let it throw you, because we will be going over this stuff in several chapters. We want to be able to improve programs by adding program content or comments, and also use the system namespace. And finally, we'll write and compile one or more complete C Sharp programs using Visual Studio. All right, computer programs are also known as software. Really, when you think of a computer systems are made up of two different things. There's hardware, and you can see that right here. That's the physical devices that make up the computer system. That's everything from the computer itself, the hard drive, everything. Something you can touch. And you've got software. So notice the author here defines software as a set of instructions that tells the computer what to do. That's a pretty good definition. There's two basic types of software. The first is system software, which most people equate with the operating system of a computer. The other is application software. And again, the author mentions that application software allows users to complete tasks. This book is all about how to use C Sharp to write application software. All right? When you write software, eventually, the only thing the computer can understand is machine language, as is mentioned on the bottom of the slide here. Machine language is a series of ones and zeros. It used to be back in the day, back in the 50s, 60s, whenever it was, that was what most people wrote computer programs in, zeros and ones. Today we've got high-level programming languages. High-level programming languages are more English-like. As mentioned here, they use words like read, write, add, etc. All right, they allow you to assign your own names to areas of memory. Those are variables, and we'll talk about that in just a minute. Each programming language has its own syntax, which are its own rules of the language. And if you say, I don't understand that, I believe everyone does. When you think about it, if you took a look at your textbook is a series of chapters. Each chapter is a series of pages. Each page is a series of paragraphs. Each paragraph is a series of sentences. Each sentence is a series of words. At the end of each sentence, you've got a period. That's one of the syntax rules of the English language. When you go to a new paragraph, you either indent or maybe you leave a blank space or whatever. Another thing people typically do for syntax. All right? Now, to take this high-level programming language, which again is very English-like, and put it into something the computer can understand, will require that you use either what's called a compiler or an interpreter. Now, C Sharp is a compiled programming language. And as it says, what a compiler does is it translates these high-level language statements, and you're going to start seeing them in this chapter, which are very English-like, into the ones and zeros that are machine language. All right? You, as a programmer, have to start to develop what's called programming logic. And what programming logic means is you have to take and figure out how to solve a computer a problem using your computer, but you have to do it within the guise of the language itself. You've got to follow its rules. Now, typically when you're developing a program, you'll make mistakes. All right? Mistakes in computers are known as bugs. The act of removing all syntax errors from a program and runtime errors and logic errors is what's known as debugging. And if, some people listen to that and they think that's kind of a weird term. Well, back in I believe it was in about the 60s, I think it was the 1960s, it could have even been the 50s. There was a woman, she died several years ago, but she was a commander in the United States Navy, about 4.5 feet tall, and her name was Grace Hopper. And one day, Grace Hopper was working on a computer program, and she was running it in bad. This was back in the days when computers were zeros and ones using machine language. And she ran her program and it gave her incorrect results. So she went back and looked at it line by line and thought that it was totally written correctly, but ran it again and still was getting incorrect results. So she wondered if the problem wasn't in the computer software, but perhaps in the hardware. That was back in the day when computers used vacuum tubes and the like, and it looked more like an old-fashioned television set. So she ended up taking the back of the computer off, and lo and behold, there was a dead moth that was embedded into the back of the computer. She took the moth out, story has it, cleaned the computer up, ran the program, and then it worked. So what she did was she found the first computer bug and she debugged the program. All right, as far as different errors, we already mentioned syntax errors. And a syntax error is an error in the rules of the language. What you'll notice when we go on in here is virtually all C# statements have to end with a semicolon. If you leave the semicolon off, where the system is expecting there to be a semicolon, that'll be a syntax error. Logic errors, a good example of a logic error is if I mean to add two numbers together, but I accidentally subtract one from the other. They're hard to find for two reasons. First of all, they give you incorrect results, but they don't stop the program from running. And second of all, most programmers like to think of themselves as being infallible. I've had people do that before where I help them find an error and they go, geez, I don't know how that got there. I didn't do that. Well, someone did. There's also another type of error that's known as a runtime error, and we'll see that a little bit later on in the book. That's a that's a type of error, as the name suggests, that doesn't get caught until you're running the program. An example of that is attempting to divide by 0. And again, you'll see that later. Okay? All right. Procedural program creates and names computer memory locations that hold values. That's a variable. A variable is a location in memory whose value may, doesn't have to, but may vary as the program is running. For a procedural program, as it says, you write a series of steps or operation to manipulate variables. All right. Now, when you work with what's called a non-object-oriented programming language, these different procedures that you write are typically known as functions. When you use an object-oriented programming language, you don't call them functions, you call them methods. All right? C# is a total object-oriented programming language. So, we are going to be seeing and writing our own methods. Every C# program somewhere has to have a main method. And again, we'll get to that as we go. All right, they talk here about camel casing and Pascal casing, and maybe it's easier just to show it to you here. That what the author actually means by this is if I'm creating a variable, let's say that the variable is called tax rate. If I do it like that, that's variable, camel casing. What that means is every letter in here is lowercase, but when you run words together, the first word first letter of every new word except for the first word itself is in uppercase. So if this was called my tax rate, it would look like this. It would look like that. That's how you set up variables in C#. Then they talk about Pascal. So for methods, the first letter is capitalized. That's what's different between those. So that's method Pascal casing. All right, you're going to see that a lot as we go on in here, but I'm just trying to introduce a few things to you in this first chapter. So again, C# is an object-oriented programming language. And with an object-oriented programming language, you work with objects, okay? When you create an object based off of what's called a class. So an object is what's referred to as an instance of a class. In fact, the act of creating an object from a class is called instancing or instantiating an object. All right? So a class is a blueprint of what an object is supposed to look like. And if that confuses you, imagine that, you don't normally see this, but let's say that a developer is going to build a new neighborhood and has 100 houses that he's putting on, or they're putting on 100 acres of land. And for whatever reason, the builder is just enthralled with one home style. So all 100 of these homes are going to look exactly the same. They're going to have the same style. But when you think about it, some of them might be sided, some of them might not be sided, some of them might be red, some of them might be blue, etc. But the class or the blueprint for the house, so the house class, would be the same for all of them. But each object could be unique. If that still confuses you, think about having a class called person. And let's say that we said each person had a height, a weight, a gender, an eye color, and a hair color. And each person could sleep and each person could eat. Well, when you think about all the people that you have in your classroom around you, you all have different eye color, hair color, you're one gender or the other, etc. All right? So these different characteristics about people like eye color, hair color, etc., those are attributes. If we say that each person can eat, can drink, can sleep, those are behaviors. Behaviors are also known as methods. All right? When you are working with an object, whatever the object has at any one time as the values for its methods and its attributes is what's called the state of the object. So as it says, with object-oriented programming, you define the objects you need to accomplish a task, and you develop classes as a blueprint to describe those objects. All right? And in fact, as we go on in here, you'll notice that every time you use a GUI in here, you're working with objects. If I create a GUI or a graphical user interface on the screen, and let's say I put two buttons on it, they're both button objects. They're both part of a button class. So again, a class, category of objects, or a type of objects. It's a blueprint. Describes the attributes and the behaviors. Each instance of a class is an object. Now, a couple more things about object-oriented programming. The first there they talk about is encapsulation. Again, you can read that yourselves and notice they talk about a black box. Now, think about this, okay? If I decided right now I was going to print out these slides, I'm not going to, but let's say I did a Control P to print out these slides. So right now, and it's not going to let me do it like this, so let's see. So I come in here and I do a Control P. All right, and I'm not connected to the printer right now, but if I click print, and let's say I was connected to the printer at work right now, and I click that, I don't physically know what happens to the computer between the time I hit the print button and something prints out, and I don't really care what happens. I just care that if I want something to be printed, it indeed gets printed. So the black box says that I can take And for example, I can use different classes, objects, attributes, and methods that have been either written for me or maybe that someone else writes, and I have to know how to use them, but I don't have to know exactly what they're doing and how they're doing it. And if you're still confused, think about it this way. What if I come in here and I bring up our old calculator, okay? So here's my calculator. And I'm going to type in the number 639, and I'm going to hit the square root key. And it comes out 25.27 plus. I don't know what happened internally in the computer between the time I typed in 639 and then hit the square root button and the time it gave me an answer. I don't care, because the logic that did that for me is encapsulated or hidden from me. All I see is what's referred to there as the interface. That was the calculator, the way that it looked on the screen. So you've got encapsulation and you've got an interface. And there's a lot more to object orientation. We're going to look at a little bit more, and you'll learn more as we go on in the book. We'll have a whole chapter, I think it's chapter 10, that's going to talk about inheritance. So for instance, let's say that I created a class that was called, let's say I created a real generic class called employee. And I said every employee had to have a first name, a last name, and an employee number. But then I decide that I want to create different types of employees. So in other words, I want a full-time employee, a part-time employee, maybe a commission type of employee, a pieceworker employee. I can start with an employee class and say all employees have a first name, last name, and an employee number. Then through inheritance, I can build, it's like, with genetic inheritance. All right, so I can create a new class that's called, for example, piecework employee. And that pieceworker, if I have it inherit from employee, automatically will have that first name, last name, and payroll number. And you'll see that again in chapter 10. Polymorphism is another object-oriented term. Think of it this way. Let's say that I created a very, and again, I'm going to show you this. It may not make a lot of sense, and really and truly, that's okay right now. But let's say that I came in here and I decided that I was going to create a class. I'm going to come down here a bit. And I was going to call this class Animal. So I create a class called Animal. Then I create some subclasses. So I'm going to create here a dog, a cat, a duck, a pig, and a horse. I'll just keep it at that. All right. So I create a class up here, and what I do is I define a special type of method, and don't worry about it because we'll get into it. It's much closer to the end of the book. But I say that I define in here a method that's called speak. Okay? Well, if I call a speak method for a dog, it should say bark or woof or whatever. But if I call it for a cat, it shouldn't say bark or woof, it should say meow. If I call it for a duck, it should say quack. For a pig, it should say oink. And for a horse, it should neigh, whinny, or whatever. So when we talk about polymorphism, which is the last thing that you saw on the slide here, what it means is that literally the system can figure out which speak method to call based on the type of object that's being used. And again, you'll see this much more in later chapters in the book. All right, so a little about C#. One thing that's not shown in here is in many ways C#, this is me speaking, my opinion, C# is Microsoft's answer to Java. It's object-oriented, it's component-oriented, it's part of the Visual Studio package. All right, but again, more than anything else, that's the biggest thing I'd say about it. Okay, is the fact that it's very similar to Java. You can write C# programs using a graphical user interface, or you can write them right from the command line. It's modeled after the C++ programming language, but C++ is one of the hardest languages there is to learn because of some things that it allows you to do and some that it doesn't allow you to do and the way that you have to do certain things. So in many ways, C# was built so that people wouldn't have to learn C++. And again, this is pronounced C#. It's similar to Java. It's similar to Visual Basic. So here's an example of a first C# program. Okay? All right. So we got a class there that's called first class, static void main. We were going to write this as my first C# program. And I'm going to go back to this in just a minute. But what I am going to do right here is I'm going to come here. And I've already got this loaded on my computer. I'm going to show my class. I'm sure Evan's going to show his class how to load that. But Visual Studio 15, I'm going to start it. Okay. I'm going to come in here, and I don't like to keep this open, so I'm going to do a File, New, Project. And I'm going to literally call this First Class because that's what the author called it. So it's going to go in and build at first class for me. All right. Now, if I do it like this, and I didn't mean to, but if I do it like this, now I can grab and put GUI features in here. So I can grab a button from over here, and I can drag it on, and there's a button. I can double-click the button, and make that a little bigger. I can double-click the button, and I can put in here, for example, okay, it's kind of a silly example, but I just want you to see this. All right, so I'm going to run the program. This is all things that we're going to be going through as the chapter goes on. But notice when I click the button, what happens? You just click me. All right. Okay, so that's all fine and dandy. But actually what I'm going to do is I'm going to come through here. And I'm going to stop debugging. And I'm going to close this project. Okay, and I'm going to come back in here. I'm going to do a File, New, Project again. But this time I'm going to choose Console Lab because that's what they showed in the book there. All right. And we call that other one First Class. So I'm going to call this one My First Class. Okay. All right, that looks very similar right here. This looks very similar to what you saw right here. So I'm going to type in this line of code that's right there. Whoops. So I'm going to type in system.console.writeline. This is my first C# program. So system.console.writeline. This is my first C# program. Okay. Now I'm going to put one more line that's not shown on the slide there. I'm going to just put in here system.console.readline. And the reason I'm going to do that is if I don't put that in, the program's going to run. It's going to be correct, but it's going to show you the output and it's going to disappear. This way that output will stay on the screen. So let me run this. This is my first C# program. Because I put the read line right here, when I hit enter, it'll stop. Now it's stopped. All right. So I just wanted you to see what that looked like. All right. So let's jump back into here. Whoops. That wasn't good. All right. So if you remember, I called mine My First Class. And when I did that, it automatically made My First Class. So this is basically what you save your project as. And again, when you are creating this, use that Pascal casing again. All right. Every C# program somewhere has to have a method named main. And that's where the program starts executing. When we first start, most of our programs only have a main method in them, but later we'll write our own methods and we'll have main call them and have other methods call other methods, etc. This is also a method call. This is saying use the system namespace and use the console and call the WriteLine method and supply to that, this is my first C# program. So you've got a lot of stuff in here. You've got a class that's named first class. Again, mine was named my first class. You've got a namespace, which is system. You've got a method, which is WriteLine. And you've got an argument to WriteLine, which is this string that says this is my first C# program. So here's how the author describes it. And I like this book. I think she's done a very nice job of going through the stuff that's in here. And I think that if you read the book, follow the directions given by the instructor, I think that you can become a very proficient C# programmer. So a namespace, as it says, is a way to provide or to group similar classes, and it can avoid what are called collisions, which are naming conflicts. C#, as it says, a method header and a method body. This is the method header right there, static void main. Inside the curly braces is the method body. And you'll learn this either in this chapter or in later chapters what all of this stuff means. So the header, as it says, includes the method name and information about information that might be passed or returned from a method. This says that we have nothing passed into the method because there's nothing in the parentheses here, and the method doesn't return anything. It is void of a return. The body within the curly braces includes all the instructions. So this one says when you call main, execute that instruction, which is exactly what happens. You can use white space, a lot of white space in this language. It's very forgiving most of the time. All right. It can make your code easier for you to read. And when you go back and look at this, this is set up pretty nice as far as white space. All right, we'll get into in later chapters what an access modifier is. You'll notice in here, you don't have any access modifiers, but we'll talk about public, we'll talk about private, we'll talk about protected, and we'll talk about internal. You'll learn about all those. All right, C# has keywords, and I don't know if the keywords are actually shown someplace in the book here. They might be in Chapter 1. All right, they might be someplace else. I'm looking up C# keywords in the dictionary in the back of the book here. And if I don't find them, I can always Google it too. And I don't see it. So I will Google it. So let's come in here and we will put in C# keywords. Oops, there. Including results for C# keywords. That's what I wanted. Okay. C# keywords. Now this is from Microsoft. So there they are. There's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 40, 60. Looks like 79 keywords. Some of the keywords that are in here were put in the language not because they have a meaning, but because they're considered bad programming practice to use them. I don't believe there's a go-to in C#. There might be, but it was put in there because there's a go-to in other languages. Some of these other words are put in here for lack of better words, more for possible future or whatever. All right. So again, I should mention to you too that what a really excellent resource here is if you go out to msdn.microsoft.com. All right. msdn.microsoft.com. msdn.microsoft.com. Right? Add to my little list here. What that is, the MSDN stands for Microsoft Developer Network. All right? That's kind of the warehouse, clearinghouse, whatever you want to call it for all things that are Microsoft.net. So if I come in here and I go and bring up the search box and I type in C#, I don't know how many thousand hits I'm going to get, but there'll be a lot. 2,070,000 hits. All right, and there's all sorts of things in there. It's always a great place to start. If you're wondering about syntax or something, going to msdn.microsoft.com is always a great place to start. Again, the name of our method was main. Every app must have a main method. Main doesn't return anything, so that's got the keyword void. I already mentioned all that stuff to you. All right. When you name a method, or when you name a class, or when you name a variable, so it's something that you have named, you are creating what's called an identifier. All right. Identifiers must begin with either an underscore, an @ sign, or a letter. I would recommend just letters. After this letter that you have for the first character, they can have more letters or digits or underscores or an @ sign. I would recommend, this is me speaking, using letters whenever possible. You might occasionally have to put in a number, but I wouldn't use anything else other than those. Whoops. And I guess it's going to show us our keywords in just a minute. So they can't be a C# keyword, and there they are. All right. So here are some examples of valid identifiers. But these would be what you would use for a class. Remember, if you're creating a variable, the first character should be lowercase. Here are some things that are illegal. You can't have a blank space in there like we have there and there. That's a keyword. It can't start with a number. It can't have that special character in there. So these are all things that you cannot do. All right. When you're starting to write yourself a C# program, and let me go back here, okay, and notice that if I come in here and I want to write something, and I start to write in here, this program was written by Jeff Scott of Rankin Technical College. Well, when I run this, I'm going to get it, and it's not going to run. You notice I get all these underlines. The system doesn't understand what I'm trying to do. But if I come in at the beginning here, I put in // notice how it turns green. That's a single line comment. So a single line comment is some descriptive thing that you put into a program that the compiler, the thing that takes your program and converts it into machine language, skips. There are 3 kinds of comments that you can have in here. There's a single line comment. Let's say I wanted a comment to stretch over multiple lines. Then I start it with a /*, and I put in here, this is my multiple line comment. Okay, so there's that one. Or I can start with 3 /. And this is what's called an XML comment. We're not going to go over that right now. Okay? So, example very similar to what I just showed you. There's a multi-line comment, there's a single comment. All right. Now, we're using that system namespace. System.console.writeline. And you know, that, not like that's terrible or anything, but that's a lot of typing. If I come in here and I come in and say use system, well, notice if I write my own, I type in using system dot, and I'm going to put a CON No, I guess I don't even need to do that. I'm going to leave off the system.console, and I'm just going to put in the word WriteLine. Let's see if we get an error. All right. And it says the name WriteLine does not exist in the current context. How about if we type in whoopsie. All right, now I've got console.WriteLine. Notice I didn't put in here system. All right, but I'm not getting an error. So if I've got the console.WriteLine and the console.ReadLine, let's run the program again, and we still get our same results. And the reason that we're able to do that, we can put in the system dot, but we didn't have to because we've got here using system. All right, so when you have these using statements, some of which are put there automatically for you, others of which you can add, it allows you to, for lack of better words, to kind of bring in different library and other kind of functions for you to use. All right. All right, there's a thing with 3 lines of output. You can take a look at that. So there's a you do it exercise in here, and that you do it exercise is on pages 20, 21, and 22. The author wants you to come in and put all this in. Maybe that's what I needed, was the word static in there. So let's go back and try that again. So using static system.console. Let's try that. So using static system.console. All right, now I should be able to get rid of the word console here and the dot and here. Notice I've got no errors. There's no squigglies or anything else. And if I run the program again, I get the same result. All right, we're going to go over all this stuff as we go on in here. So please, it's not at all my intention to confuse you. But I'm going to assume that you're going to be able to go through the exercise that's on pages 20, 21, and 22 by yourself or under the guise of your instructor. And when you get done, that you will be able to come in and also then compile and execute the program. Notice as it says, when you compile a program in this language, you compile it into what's called IL or intermediate language. And technically that's not even correct. You actually compile it into what's called MSIL, where the MS stands for Microsoft. All right. The C# just-in-time or JIT compiler translates that intermediate code into executable statements. All right. And I already showed you both of these. I showed you the command line, but remember the first thing I showed you was I put the button in there. When we clicked it, it said you just click the button. So you've already seen how to compile and how to run from the command line and how to compile and how to run from the IDE, a GUI, a graphical user interface. Now, I'm not going to spend any more time on that right now because the idea here is to go through the PowerPoints. Occasionally, you're going to have mistakes. In fact, let's put a mistake in here. So I'm going to go in here and I'm going to grab, and where I have this read line, I'm going to put a few mistakes in here. First, I'm going to take out one of the parentheses. All right, so there's a open and close parenthesis. I'm going to take out that one. So now I have in there an open parenthesis, but not a closed one. You can already see I'm getting a red squiggly line here. But I'm going to run the program. And it says there were build errors. When it says, would you like to continue and run the last build? No. And then down here it shows me. In fact, if I double click on the error, it shows me the line in question and it says it expected a right parenthesis. So when I put that in, it all goes away. If I come in here and I remove the semicolon, it comes down and it says semicolon expected. One that you're probably going to do a lot because we all do it is where we've got read line. You're going to come in here and that L you're going to make lowercase, and this is a case sensitive language. Now it doesn't understand what you're trying to do. So again, I run the program. Again, it says errors, no. And it comes through and it says the name read line does not exist. And you go, no, that's right. No, wait a minute, that's good. That should be a big L. These are mistakes that not only do beginning programmers make, all programmers make. All right, so you're going to have plenty of time to go through and get really good at debugging C# programs. You're going to get messages like this, compiler-generated error messages. Now, when you use the IDE, and IDE is an acronym which stands for Integrated Development Environment. When you use that, it's much easier to work with a GUI, but even when we didn't work with the GUI, hopefully you notice the comments, for example, were in green, keywords are in blue, etc. So the IDE, our environment, our Integrated Development Environment, which is Visual Studio 2015, which is what we're using, all right, makes it easier for you to write code. Okay, here is an example of the IDE. In fact, let's look at it in the guise of actually right here. All right, and again, if you're following along, it looks like I'm on about page 26 of our textbook. All right, and when you look here, okay, this program is not a GUI program. It's not a graphical user interface program. So our toolbox is empty because there are no tools we can put there. This over here has a listing of all our files. This is the file we're working on. All right, program.cs. And there are other files that are in here that the system needs in order to be able to do its job. As we go on in here, you'll get to learn what all this stuff means. You'll have to take my word for it right now, but you will. All right, I already showed you some compile errors and where the error messages go, etc. So we've already gone through that. All right. Advantages of using the IDE. Those using statements were put in there for us. The curly braces, etc. were put in there for us. You can, if you want to, it is totally legitimate. You can, C-A-N, you can write a C# program just using Notepad. I don't know why you do it, but you could. Again, you might want to write a command line program because it's typically smaller. You'll probably want to use the Visual Studio IDE because it gives you auto help. It has syntax coloring, and it automatically generates some code for you. So in Notepad, you'd have to type in this, but you'd also have to add this stuff to get it to work. It's more work. So there's another You Do It exercise here, and that is on pages 30, 31, 32, 33, 34, 35, and 36. It's a simple Hello World program. All right, and I'll let you go through and run through that one yourselves. All right, the author explains everything that's in there. So in this first chapter, what we did, we talked about what a computer program was. A set of instructions that tell the computer what to do. It's also known as software. Remember, there's two types of software. There's system software, which is basically the operating system, and there's application software. You've already written a couple application software programs. We talked about the difference between procedural programming and object-oriented programming. All right. We mentioned that C# is a totally object-oriented program. It works with classes, it works with objects, it works with attributes, and it works with methods. We looked at things like system.console.writeLine to produce a line of output. We did not put any variables in. You want to quickly see one, just so you can see what it's like. How about this? What if we go back to our program here? This is my first C program. I'm going to come in here and I'm going to do this. Oops, I don't want to do that. All right. So this is my first name, and I'm going to put another right line in here. My first C# program, so I'm going to put in here another right line. And I'm going to say it was written by, and I'm going to put a plus sign here, my name. Okay, now this may not look like much of anything to you, but let's look at what we just did. This is our variable declaration. This is our variable initialization. So we're creating a variable that's a string that's called my name, and we're assigning the value Jeff Scott to it. So let's go run this. Now notice this was my first C# program. It was written by Jeff Scott. All right. We looked at different types of comments. We looked at namespaces, and we talked a little bit about the Microsoft Visual Studio IDE, or Integrated Development Environment. We also went out to msdn.microsoft.com. In the next chapter, Chapter 2, which starts in our book on page 47, it's called Using Data. And we'll learn in there about variables and the different types of variables that exist. And I'll be back with that shortly.